Hi, welcome everyone to the Data Science Seminar Series at the University of San Francisco, sponsored by the Data Institute. For those of you that don't know me, my name is Liz Merkel and I work here at the Data Institute. I don't see enough of you students, so I just want to say hello, and it's so great to see all of you here today. And I want to welcome external members of our community as well. We're happy to have you here too. Our speaker today is Dr. Interian, who told me that I could say whatever I wanted in this introduction, but I'm choosing to stick with the script that I was given, which is that Yannette is an associate professor here in the MSDS program, and her research interests lie in the application of machine learning and deep learning. She holds a PhD in applied mathematics from Cornell and a BS in mathematics from the University of Havana in Cuba. After a postdoctoral fellowship at UC Berkeley, she worked for 5 years as a data scientist at Google. She co-founded Akua Lab, a startup that helped organizations develop data-driven products using machine intelligence. So she's like not smart at all. But anyway, today's talk will be about the capabilities of the Huggingface API, providing access to state-of-the-art language models. In the talk, we will gain valuable insights into how pre-trained language models, LLMs, can proficiently handle a range of NLP tasks without requiring extensive training. Additionally, the talk will explore the intricate process of fine-tuning models for specific tasks, allowing for customization and adaptation to legal datasets. With that, I'm going to give a round of applause to Yannette.
Thank you. So guys, I guess you now all work with ChatGPT all the time, you know. We didn't grow up like that, you know. It was it's been just like a year, right, since we have learned about ChatGPT. So, and it's so cool, no? So interesting. So for a while, I have been thinking that I had to get my hands on to these free models out there, because there is ChatGPT, which is proprietary model, right? So we cannot get access to the actual model. But there are a bunch of models out there that are getting more and more better. They're getting better. They're also, most of them are smaller. You know, how do you guys know how big is like ChatGPT? Like, I think it's like 175 billion or something like that, right? So the models we're talking about today are, you know, millions, you know, not billions, right? But a lot of them are pretty useful at tasks that you guys would face in a regular job, right? So you may not need. So we can also use a ChatGPT API. So we have used some of that, but you cannot train ChatGPT, right? So you can use it for certain things. We have talked about how to prompt ChatGPT, right, in class. But you cannot get access to the actual model, right? So anyway, so today I want to get more into the question is like, how do we get into actual a model that is free? There are many of them out there, right? So I wanted to introduce you to Huggingface API. So Huggingface is a company. It's also a repository of models and also data sets, and it's mostly known for the NLP models. So all the large language models is mostly known for their transformer library. So they have a transformer library with a bunch of models. And they also have code to deal with those models. To be honest, it's been frustrating for me to deal with their models, right? So what am I gonna do today? I'm just gonna show you how to use their models and so on, but also how to train their models using PyTorch. And they have their own, they have a lot of different functions, and you're gonna have to kind of learn a little bit how to deal and handle them. And they have some tutorials, but you know, anyways, it's gonna take a little bit of getting used to. And they have a nice course that you can take that helps you a little bit. So they're actually the French person that narrates most of the class. He used to hang out with us a little bit. He was working for Fast AI at some point when Fast AI was based here in the USF. So anyways, and a lot of the ideas on how it was built, they are similar to Fast AI, which was a library. It's a library for deep learning. But you know I like PyTorch, right? So I'm gonna boil it down to PyTorch, and then I think it's gonna be better for you to see that part. Okay, so the first thing I wanted to show you the library, and there are many models, guys. And I actually, to be honest, I don't know all of it either. I've been trying to, and how you learn about this? Well, the internet, you know. You ask ChatGPT about it. You ask. There is a new GPT that I'm using. It's called Perplexity AI. Really good. It's free. It's on the internet, so it is pretty good. So if you wanna check it out. So okay. So basically, what we have here are the Huggingface models. And again, to actually understand which one is good for what, you have to kind of you just follow the internet, understand the documentation, understand what data sets that they fine tune on, and so depending on the data sets, and then you have to understand also a little bit of what the data sets are good for, and then you understand which task each model is going to be good at. Okay. A lot of what I'm going to show you, I found examples on the internet on how to use it. Then I try other models, and those models don't work. And then I was like, oh, okay. So these particular models were trained to do this, right? So you're gonna see I'm gonna use particular models. Then some other models may do other things, and you have to kind of figure out which model does what, basically. So it's interesting. It's still also it's a start of all of this. So this is gonna change all the time, and we just have to start getting used to it, right? So anyways, with that in mind, I also had some slides that I decided to skip. And let's go to look at some code, okay? Because otherwise we don't have time. So the first thing is, so sentiment analysis is it's a task of assigning sentiment to some piece of text. And there is this data set that is very nice from Stanford that has pieces of reviews, and the reviews are classified either as positive or negative, okay? So they have like 25,000 of movie reviews for training and for testing. So the first thing I did was to, I am working with sets that are not on. So they have a lot of data sets on Huggingface, but I'm trying to work as if you guys come from your practicum, your internship, and you have some data that is basically on your computer, right? So here, basically, each one of these reviews is in a directory. So I have a function that opens and reads the review, and so this is one of the reviews, right? So it looks like this. So the first thing that you have to do when you basically there is something called the pipeline in Huggingface, and this is kind of the simplest way you can use Huggingface. You can just call the pipeline and send, hey, I want to do a sentiment analysis task. Okay, just to say that, and you give it some data that says, I love you, I hate you, and the pipeline is going to go and say, hey, okay, well, label, the first one, label positive, the second one, label negative. Okay, so the pipeline is picking up a model that is going to be good by default at this particular task. Okay, you can also specify the model, and basically you can also say that. So I'll show you how to specify the model. I think down here. Okay, I'll show you that. Ignore all these warnings are red, but they're not really important. So basically, what I did is I took my pipeline. And I try to, so you decide, well, this is a sentiment pipeline. So you say pipeline sentiment analysis. As simple as that. And you take max length is basically every one of these models take a maximum number of tokens in. Okay? So, and if you don't put max length and your data is longer than that, sometimes it will break. So you have to keep that in mind. So different models will take different amount of the context or of the length of your data, depending on the model. So there are some models out there that are taking more than 512 tokens, but most models right now on Huggingface take 512 tokens. So you have to put this much length there. So as you can see, this pipeline scores positive sentiment perfectly. I just took 10 examples to show you, but it scored them, also it scored them with very high accuracy as well, high probability as well, right? And then I tried like also like 10 negative, and it's getting 2 of them positives. But most of them, for some reason, the probabilities are high for everything, which, you know, it's worrisome, right? But deep learning models are kind of like that. They like to be very sure of everything. Okay, so okay, guys. So any questions so far about this? So basically, if you have a sentiment classification task, you don't have any work to do, more or less. You just go to this library, take a pipeline, and try to score, and try to just see what happens to your data, like just like that. Okay, we can do more sophisticated things. I'm going to show you that later, but at least you can try. This is your first model, your baseline. Yeah.
I thought you just put in 2, like 11 by 8 or something, but you're showing 10.
Okay. This is my own data. It's my own data.
Oh.
Yeah, let me. Sorry about that. I first started with this, but actually, if you see here.
Okay.
Yeah. Sorry about that. I kind of skipped that line. So I have this data set of reviews. And I have all of the paths in here, and I am taking the first like 10 of them, and they are in different subdirectories. The positive are in one directory, the negatives are in the other one. So I'm pulling, for the data 1 are the positive, and the data 2 are the negatives. I'm taking 10 of them, and By the way, I have all of these in a repo that is free and open, so it's public repo right here. So if you want this code later, maybe I'm gonna write it down here so that you can check this out later. So it's my username. Keep learning. Yeah, so the ones I'm talking about today are the second and the third notebook here. Please ask me questions if something is not clear. Okay, so I have this my own data set here, and I was just showing you how you can just go ahead and just use this pipeline to score your own data as positive or negative, and it's not making too many mistakes. I didn't have enough time to compare this to the results we got from querying ChatGPT, which we did, right? We did on one class that we had. I'll have to do that. The good thing about this is that this one is very fast. When you are using ChatGPT and you are using the API, it's slow, and you're paying for it. But it's also slow. This one, because you have the model on, the model is on this machine right now, it's very fast. So the inference time is super fast. So, okay, and basically this notebook, the one where I'm talking about right now, runs on my machine. The next notebook that I'm going to show you that is training a model, I run it on the GPU. But this one here, that is just inference. You're just using the model to make predictions. You can just run this on your laptop easily. Like, it doesn't take that time at all. Just a tiny bit of time, kind of maybe loading the model. We can actually do it. Like, let me actually show you it right here. When we load the model, maybe it's going to take a bit of time. So I think I haven't run it right now. So let's just run this. So loads the model takes a tiny bit of time, but then you're going to see scoring doesn't take time. Well, let's keep going and hope that this is going to load very fast. So I'm gonna just, okay, you see, it takes a tiny bit of time, but I may complain about some stuff, it's not that important, but it's giving you that. Okay, so to be honest, if you read some, hey, what are you? I know, yeah. So two positive, yeah, there's two mistakes, yeah. Okay. So you can also pick a particular model to use. The default model is this model called Twitter Roberta Bay Sentiment Latest. So this is actually the model that is by default used here. But if you had another model, you can just say model equal model. Actually, no. The default model is a different one, and I use another one that can also be used, because now you're gonna see how this other model is making a little bit of more mistakes. So what happened is that I used the baseline model, I looked at it, and then I was like, what other model can we use for this? And it turns out that the default model was better than the one I found on the internet that can also be used for this. So different models can be used for this particular task. Okay. Any questions? No? Good. Good. So second task, text summarization. So I found a dataset on the internet. You can download it from here. That has an article and some kind of summary of the article. Okay. It's difficult. Scoring and trying to figure out how well a dataset does in summarization is difficult. So I'm not going to do that. So I'm just going to show you how to use it, and I'm going to show you what it does. So basically we have this article, and you can read it later, and then you can we have this summary or highlights, and then we can ask the model to go and so here it's a pipeline summarization. You put a particular model, T5 base. The T5 models are some models that come from Google. I have been using them a lot. There is another one called, so there is T5 base, and I have been using more of this called Flank T5. They come at different sizes also. So they're small, medium, so there are different sizes of them. And these are not the biggest ones. And I just want to point out, so I just have an example from this set so I would like you guys to compare what the first model does. That, for example, the capital letters or the spaces in weird places, there is no capital letter in the bishop at the beginning, to the slightly more sophisticated Flank T5 base. They have the same size. It's just that Flank T5 have been trained slightly more than with a different task than just T5 base, okay? And so this second model does much better. I don't know if can you see both of them? So one of them is this one here, and the other one is that one there? Yeah.
Off the top of my head, I wouldn't say the second one is better. The first one is shorter. If that's what you're more interested in, I mean, you have to weigh that against grammar.
That is true. That is true. On the other hand, if you see the first one, you see like a language model that is not yet. For example, these language models are very, very good at putting capital letters, and I don't. You see the bishop and it's in lowercase, and then the period is. Separated from the last.
Sure, the syntax sucks, but
exactly,
but
the
the
syntax,
condensation is more condensed.
Yeah, I'm being kind of superficial about it, but those things, the syntax, is the first thing that these language models learn really well. So if you talk to ChatGPT, he's gonna be perfect. He's gonna, if you ask him to rewrite something, he will be perfect at that. He will, and if you ask to check grammar, he will check the grammar. He explain what errors you have. He will do many things, right? So one of the things you look at is like what type of language is generating, and superficially, that first answer seems to be less good at these superficial things.
If I hadn't read the original and only you saw that, I'd be concerned that it's a good summary.
Yeah, okay. So, I mean, it's great that you feel that even the first model that maybe is not that good is doing an okay job, right? And then we have the second one. My point is that you guys not only have to, when you're doing this, part of your job is to figure out which are the best models for your tasks, right? Right, so this is part of the whole thing about ordering this information is becoming an expert on what models are out there, how big are they, how good are their particular tasks, and then if you have a particular task, you will have to go around and find what are the best models for that, right? But it's pretty simple, no? It's pretty amazing in a way that these models are free and can be used, right? So I wanted to introduce this idea of zero-shot classification. Yeah.
Do you know when those models were trained? Are they recent or no?
Say again?
Do you know when those models were trained? Are they
Those models, some of them are very recent, but each one of them, it has a model card, and they tell you all that information. Yeah. So, and the paper, by the T-Flank paper, I think it's pretty recent. The paper itself is a paper by Google, basically trying to make smaller models that are training well, but just a different size. But I don't remember the details very well. But the library, every model has a card, and it explains a lot. Like the card explains like when it was trained, and what tasks they were trained on, and so on. Yeah. And I think a lot of things about learning all of this is, understanding a bit more about the tasks that they were trained on, understanding a bit more about the datasets they were trained on, like all of that will make you a bit more of an expert on how to use this library. Mm-hmm. Okay, the next thing I want to talk about, a bit about zero-shot classification. I find this idea kind of crazy in a way. Like if you have told me this a couple of years ago, I'll be like, oh, maybe like 5 years ago, I'll be like, no, that doesn't make sense, So it's this idea that you have a model that doesn't know anything about your data at all. Because the previous models were trained on summarization. Maybe not on your data, but they were trained for that task. Or it was trained on sentiment analysis, okay? But this next model I'm going to show it to you, you're just going to say, hey, I am interested in these classes. The words have to make sense, right? But he will score what he thinks are the probability of that class without any training. And that's a little bit crazy, no? Right? Don't you think? Okay? So they were kind of trained to do this in some ways, but it still, to me, feels like it's a lot more power than even the first two that were really trained for a particular task. So we know what summarization is, and we can train models to do summarization. We know what sentiment analysis is, and we can train models for sentiment analysis. But now this is more general. You're just saying, hey, so I found this dataset. It's like a news data set, and it has every news has some category. So what I did is I said, well, I'm going to lowercase all these categories, and I'm going to feed it to a model and say, I'm interested in classifying in these categories, right? And then please give me probabilities on this. So these are all the categories of the data set. I was a bit lazy, so I just used a few of them, and I am using a model that people say is good at this. It's a Facebook BART Large, MNLI. MNLI is a particular data set that is also, you can read about it. It's one data set that people use to score models like Gemini and these Google models and ChatGPT and so on. Do you guys know that recently the Google model is better than ChatGPT? Interesting. But apparently this model is super big. That's trying to figure out how to win this competition. So basically, I am using this model here, and I am telling him these are my categories: news, comedy, parenting, world news. So I just lowercase the same names, right? And then I am trying to, and I basically go and say, well, I'm gonna feed the text, and I'm gonna tell them these are my categories. I'm gonna see what it does. So basically what it's gonna do is gonna say, well, I'm gonna give probabilities to each one of those categories. And so this is how it does it for a bunch of different examples. And if we compare the actual category, let me tell you this, I was trying to do this in the right way, but it's difficult. So the first one here is the actual. So, and this one is the predicted one. So the first one is right? And you can look at that later. The second one is also right. Well, the third one, it predicted parenting, and the actual thing about comedy. I mean, I guess parenting is like comedy, but I don't know. So that doesn't sound. But again, I don't know if that's set that well either. To tell you that I read everything, I thought that the model is more right. That I mean, until you have a dog, you don't understand what to be. Well, I mean, I don't know. Is that the right one? Yeah, it's like, yeah, I don't know about this. Is it? It looks comedy, but the model for it was parenting, but so so basically parenting, actual predicted parenting. So anyways, I just want to give you an idea that there are a bunch of, so this is we have talked about 3 tasks, right? One is sentiment analysis, the other one is summarization, and the third one is kind of more general. It's just basically if you have some text-based data and you have some categories that one word can encapsulate that text in a reasonable way, then you may have a reasonable model that will give you at least some probabilities. Make sense? Okay. So this is just the basic use of this library, the most basic use of the library. Next, I want to show you more how can we fine-tune models for a particular task. So we have talked about fine-tuning a little bit in our classes, but the idea is that fine-tuning is that you have a model that has been trained by one of these companies, Google or Facebook and so on, OpenAI, and you would like to modify the training so that the model could learn a little bit from the model original training, but it's also using your own labels. So you're mapping from you're mapping your text through the model, but you would like to predict new labels. Okay, so I'm going to do this in some naive way and then in some less naive way. Okay, so the first part is going to be a more naive way, but you can use this for your submission of your project on Monday. And the question is going to be, which is the best model to use? Model trained in Spanish, maybe? Yeah, for the background, they have a project due in my class on Monday, and there is some text in Spanish. So they have to encode that text into some reasonable way, together with, so the first part of this is for you, for the model. Okay, so we have a data set, a different data set. It's called a subjectivity data set. And so it has 5,000 sentences that are subjective and 5,000 sentences that are objective. And the idea is that they took different sentences from a movie review data set. And if the sentence was talking about the plot, they call it objective. And if the sentence is more talking about sentiment, I guess, they call it objective. Okay? So this is a classification dataset. So I like it because it's kind of short and sweet. So I use it a lot. So let's try to use somehow some of these models to. So the way to think about these large language models, what are they doing for you? One way to think about it is that they can encode your text into some representation. You can call that representation an embedding. So you are embedding, you are getting a vector. That vector has the same size, no matter the input that you give it. Okay? So you are encoding your text into some vector. And then you could do many things with that vector. The first thing you can do is to save the vector and put it into logistic regression. Make sense? So don't train the vector at all. Just take it as an input. It's going to be reasonable, because it has been trained on a lot of very difficult tasks before. Your task probably is not that difficult. Sorry. It's not as difficult as summarizing text, right? So it's going to give you a reasonable representation of your text. And then from there you can use logistic regression, you can use gradient boosting, you can use any algorithm given that representation to get an output. That's the first thing I'm going to show you how to do. The second thing I'm going to show you how to do is more, let's go and train the model as well. And it's a good topic to talk about later on at some other time, is what is the best way to do that. Today I'm not going to show you what is the best way to do that, I'm going to show you one way to do that. There are many techniques that people have been talking about, and especially if you have a bigger model. This model is not that big. It runs on my really okay GPU with a low batch size, so it's not that big. But if you had a bigger model, if you have a lot of data, maybe you want to think about what is the best way to fine-tune these models. Today we're going to find a way to do it. We can talk about later some papers on how people are doing it in a different way. So we have our data. Our data is, as I was telling you, so they are like basically some sentences. So here we need, actually, this is on my GPU, this is my CPU, so my GPU is here. So actually this, in case we want to run this, we can run it. So here we have to actually understand a bit more about this transformer library. And I have been learning about it, to be honest, so I'm still learning about it. So for example, there is this, my favorite model is Fluenty 5, small. Again, there is Fluenty 5 base, which is going to be bigger. I wanted to start with a smaller model because I know my GPU is not the best, so I don't know what I can train. So this one actually trains very reasonably, very fast. But it would be interesting to go and try a larger model and see if I get better results, right? I didn't have time to do that. So the first thing you want to know about these language models is that they come with everything. So they come with what they call their tokenizer. If you guys remember, in some of our classes, we have tokenized text. So what do we do? So in general, so we divide, the text maybe in words, right? And after we divide in words, every token gets an ID. Remember, we get an ID, and the ID is what we use in any way that we are training the model, right? And in these large language models, the IDs then becomes embedding, and then at some point we're going to talk about the model itself a bit better. The cool thing about these large language models is that they already come with their tokenizer, because they were trained. There are different ways of tokenizing the data. So actually, what people do most of the time is that they don't tokenize in words. They tokenize in subwords. But every model has been doing this in a slightly different way. So they come with their own tokenizer. And Huggingface has also some nice functions to deal with this data that we're gonna talk about. So the first thing you can do is to say, hey, give me the tokenizer. So you see here T5 tokenizer. So all the T5 models, apparently, I guess, have the same tokenizer. Okay. And then there are like two different models you can get. You can get the whole model by calling T5 for conditional generation. That will generate text for you. Or you can call the encoder. And the encoder is the one that is going to give you this numerical representation. And there are different types of models. So depending on your model, this will be a tiny bit different. And again, the website will tell you more about it. We're just going to show you how we use this one in particular. So for example, if you tokenize something and you use the conditional generation model, which is not what I'm going to do today, but I just wanted to show you, you can just say, hey, could you translate English to Spanish? How old are you? Let me tell you that it doesn't do a good job at that. It's not cuántos años están, es cuántos años tienes. Or tiene. So this is a small model. I think it was not even trained in Spanish translation, the poor thing. But it's doing an okay job, let me tell you. So somebody can understand that these two things are the same, they just have grammatical problems, right? But they're kind of the same. And again, this is not ChatGPT, this is something small. Okay, but so you can use these models for text generation in the same way you use ChatGPT by getting the conditional conditional API. So this T4 for condition generation will basically, you have a prompt, it will give you something. And you should try it maybe with a bigger model, maybe try to figure out which one is the best for what you're trying to do, but it's generating text for you. So that's cool. So the next thing I want to show you is how, instead of doing that, I would like to get a vector representation of my piece of text. So for that, instead, what you want to get is the T5 encoder model. So you get the model, and then you need to tokenize it. Okay, I actually talked about the tokenizer, but I didn't show you the tokenizer. So when you actually tokenize, you get two things. Let me actually run this. I'm sure it's going to break because I haven't really defined things. So let's actually define things. Let me run everything I need. So I'm hoping this is okay. Let's see if it now works. This is where is it organized? Okay, let's run it again and see that maybe I have to import the tokenizer. So what is it? We have to define it. Okay, right here. So right here you define. Basically, remember, you always have to pick your model, and you have to. All the defined models come from here. In every model card, you're gonna find an example on how to use it. So that's how you figure out which is the right thing to call that model. So that the model card will tell you that. Okay, so we did that, and we run here. And I just wanted to show you, if I just use the tokenizer itself, what do I get? Oh, okay, so I have to take this out. Yeah, so I get the input IDs. These are the IDs that correspond to each of the tokens of that input. And also we get an attention mask. And you're gonna see that the attention mask is gonna be important, not that much right now because we just have one sentence, but it's gonna be important in a second. The attention mask, when you are tokenizing a batch of data, you're gonna have to pad some of the data because your data is gonna have a different amount of sequence of tokens, right? And if you remember, we have talked about the fact that in PyTorch, we use tensors, and they have to be of the same size. So to be able to do that, when you tokenize a batch of data, you're gonna have to pad, you're gonna put some padding, it's called like some zeros, something to make everything the same size, okay? So you have to be, you're using batches, you have to worry about it. You have to make sure that you, yeah, so I'm gonna show you later because our model is gonna become a little bit ugly because of that fact. Because we need to worry about the fact that we're padding sequences. Okay, so those are the ideas that we get from a tokenizer. And then we have our model, our encoder model from pretrained. And given these input IDs, I can just try to get the output. So let me show you the output. The output is actually a dictionary that has something called last hidden layer, which is the only thing you care about. So I'm going to, so you see, it just has this last hidden layer. And then the key to all of these guys, when you have, when you're using PyTorch, is to always look at the shapes. So we get something that has shape 1, 11, 5, 12. Can you guys tell me what is the 1? We just have one input, one sentence, right? Can you guess what is the 11? It has 11 tokens, okay? And what is this 512? Okay? It's embedded size. So we haven't talked about this, but I heard that you have had many lectures about what is a transformer model. But I'll tell you, so I'm not talking about this right here, but I'm just gonna tell you what the output looks like. So you have a black box. You have some IDs coming in, you know, these 1, 10, 17, 1 again, 0. So you have these IDs coming in. And what you get out is some vectors. This is 512 for each token. And these vectors are the representation of your token in the context of the other tokens. Who knows what that means, but yeah, it's a representation of that token, and that representation is taking into account what is around. So the word cat is going to have a representation when the sentence is my cat is cute, and it's going to have a different representation, hopefully related, when you say my cat is not cute. You know, so these are going to be two different representations of the same word. And it has to do also with the words around it as well, okay? So what we're gonna do is that we are going to do, the issue is that you're gonna have a classifier, and you want this classifier that no matter the size of the input gives you one vector. So one naive thing to do, but that's what people do a lot of the time, do a naive thing, is just to take the average of these vectors in each dimension to get one vector of size 512. And that would be the representation that you are going to be using for your input text. Does it make sense? Right? The good thing about that is that no matter how long is your text, you're always, given that it goes through the model, which is another question. If it is too long, then you're going to have to cut it in pieces to take it through the model. But it doesn't matter what input you have, you're going to have an output that is going to have the same shape. And then from there, you can then train the model. Makes sense, right? Like, we have to do something to make this model have the same shape for any text we have, right? So that's what we want to do, okay? So the first part of my code here, what it's going to be doing, it's going to be doing that. So it's going to take so we split the data into training validation, and we have a bunch of different, this is our training data, X-train. These are 5 sentences from our training data, and our labels are 0, 1. So I have this code here that is exactly doing that. So basically what it's doing is like taking the input IDs, 1 sentence at a time, and then it's going to input that into the model, and it's going to just do torch min. Dimension 1, you can figure that out by playing around. But torch. Dimension 1 is just because, remember, it's 1, 11, 512. So you want to take that 11 and delete it, just kind of get rid of it. Mm-hmm. And then this code here, which you can paste and copy into your project, is going to give you an NumPy array for a piece of text. You also have to copy this stuff in front. And maybe you have to install some code too, right? But it should work. So basically, and that will give you, so when you do that, that will give you this vector, and this vector have size 512, okay? So what do you do after that? Well, you can say, well, let's actually go and, you put them all together, you stack them, you run that for a little bit, right? This takes a little bit of time to run, but not that much. And you get, what do you get? So you get a NumPy array that is 8,000 by 512. What is 8,000 again?
The number of sentences.
That's the size of my trained data, right? So I have 8,000 pieces of text, yeah. And those are the training data, and the test data is 2,000, right? So I did that. I take them all through this process, and after that, I have a NumPy array, right? So I can do whatever I want with that. So the first thing is, let me just do logistic regression. You roll, scikit-learn, and you train that, and you get a score of 90, kind of close to 94. Did I tell you that gradient boosting was the best thing ever? I did tell you that. It doesn't do better in here. In some ways, because gradient boosting is very good when you have data that is non-homogeneous in a way, like every column has its own thing going on, so yeah, most of the time it's better, but not always better. Yeah. So okay, so any questions about the first baseline model that we have? So the baseline model, again, we're not doing anything. We're just taking the model to get that vector. Which again is something that you cannot do with ChatGPT. You cannot get that vector from ChatGPT. Right? ChatGPT can help you to create labels, but not to, it's not going to give you a vector. So the next thing is to fine tune this model. So that's the next thing I'm going to show you how to do. So any questions on the first part? No? All good? Yeah.
Just the averaging that you did over there, since each one is 512 already, you're not adjusting the size of it. So what is happening when you're averaging? You're essentially taking those words and saying, well, this is the average representation of that group?
Yeah.
And do we know what is preserved and what is lost when we do that?
I don't think we do. I don't think we do. Yeah. The main problem is what I told you before, that since our input always have a different size, we have to find somehow a way to combine them in some ways. Mm-hmm. Yeah. And this is what most people do for different classification. Yeah. Okay, so let's actually look a little bit more at, I don't want you guys to be too concerned about this code here. I'm gonna show you what it does, and I'm gonna tell you why it's a little bit more complicated. But let me actually first show you what happens when you have you tokenize in batches. So remember, like, we wanna train in batches. So what does it mean to train in batches? It means that we want to consider not just one data point, but many data points at the same time. So here, this is what happens when you tokenize multiple sentences, and you say, hey, padding equal true. It means that it's gonna take the maximum length of the maximum sentence in the batch, and it's gonna put zeros everywhere to pad, basically. Truncation equal true is because the language model may have a maximum number of tokens, all of them have, and if your sequence is longer than that, it's just gonna truncate. Mm-hmm. Yeah.
Sorry, I didn't understand what's the point of the padding.
Yeah. So PyTorch works with tensors.
Yes.
The tensor cannot have, a list could have maybe sequences that have different length, but the tensor cannot.
Right.
It has to be like more than, it has to be like 10, 20, 512.
So if you have like 3 short sentences and a long sentence, you need to pad the short ones? Okay.
Yeah. And there is a shortcut to that I'll show you another time. But in principle, you pad everything together, like all of the sequences together. There is something called dynamic batching that you put padding just on at the level of the batch, not at the level of the whole dataset. And I can show you how to do that. Yeah.
So when you truncate each text string, it's like cut the text.
It cut the text. It cuts the text. It's just basically, if your text have more than 512 tokens, it will just get rid of the end of it.
So doesn't it change the meaning of that text?
Yeah, welcome to life, yeah. For some people here in the practicum, this is what they have for living. Yeah, you have to, when you have very large text, what to publicar, yeah, when you have really large text, it's a problem. And you have to think about what to do, but that's, you have to take that into account. In here, it's not gonna be a big deal because these sentences are short, so maybe it's gonna cut a little bit, but it's not a big deal. And in most cases, might not be a big deal, but otherwise you have to think about that. Okay, so any other questions about this, about batching? Yeah? Good. Okay. So the issue now is the following, guys. So suppose I have this sentence is, let me actually, 0 is a wrong number because 0 is what we use for padding. But suppose that we have this sentence here that is like 1, 2, 3, 4, 5, right? That gives me 1, 2, 3, 4, 5, right? But then I have another sentence that has just like 3 words. 3, 7, and 25, okay? So what we have to do is that we have to add 2 zeros here. What happened when I put this sentence through the model? These 2 things is just padding. So if I take a sum or an average, I am diluting the information of my representation. So what I really have to do in these cases is that I have to like multiply this by 0, count the number of non-zero things I have, I have to sum them and divide it by 3. Yeah, and that's why the code I'm gonna show you is ugly. It's just doing that. It's just, I'm gonna show you, it's just taking the output and then doing what it has to do to get rid of the things that that is padding, or the vectors that are just like the padding vectors, and dividing, summing and dividing by the right numbers. Okay, so that's basically what it's doing. But it's a PyTorch model, basically. So what we do here in our init is that we call our model. Okay, dropout is a very interesting layer that we use to improve generalization in training. And then we have our classifier, which is a linear layer that is going from 512 in this case. So actually, I didn't tell you about this and I wanted to show you this. So every model has something called a config, and the config already has some information about the model. So if you read here, it tells you a bunch of things about this is a transformer model, so it's a bunch of different parameters of this particular transformer model, and then it tells you, look at this. It's kind of telling you that it has been, to me, this means it's been trained on all of that. So it comes with translation from English to German, English to French, English to Romanian, I don't know. Yeah, Romanian. So anyways, you can play around and get information about this model by looking at this config. So on one of this information is this D model, D_model, and this is the size of the embedding that you're getting. So we need that size to take a linear layer. It's gonna go from 512 to do our, kind of logistic regression at the end of the model, 512 to the amount of labels we have. Since we have a binary classification class, we're gonna go from 512 to 1 to predict the positive class. Mm-hmm. So that's basically the first part of the model. Let me just kind of show you that. So this is what is happening here. I'm just defining all the layers that I have. Right? We've seen that before, no? And then it comes a forward. And the forward takes 2 inputs. The input IDs and the attention mask. The attention mask is going to tell the model whether are the real tokens and what are the value. Mm-hmm. So we take our model through our IDs through the model, and we then get this last hidden state, which is this tensor here. So the tensor, remember, this is for 1 token, so it's gonna have, it's gonna be a few of these, depending on how many sentences going, right? So we saw the shape of that. The shape of that is, we saw it before. You remember it was 1, 11, 512. So it's gonna be, in general, it's gonna be the batch size that we have. Maybe in this case it's 2. The length, the maximum length of the sequences in that case is like 5, right? And then 512, okay? This is gonna become from the data itself, the maximum length of your data. This is your batch size, it's just whatever batch size you are using for training, okay? And this is given by the model. So okay, and guys, this part here is just what I just told you. You're masking out the padding tokens before calculating the mean. That's actually what happened there. So I don't want you to worry too much about it. I asked both ChatGPT and Explainability AI, I forgot what the other one, to come up with this code for me. And one of them did it. It was not ChatGPT. Okay, so this is, we call this output. Actually, this has to be deleted, and I don't know how all of this run. This has to be deleted. It's just that. This is the previous one. This is the naive one. Interesting that this even run as deleted. And then basically we have to take this to training. So to train in batches, I show you how this looked like before. We can tokenize the whole data set. So let me show you. So we tokenize the whole data set, and then we write a data set. So the data set, we have our X. So we are basically gonna get in X and Y, where X is gonna be the output of the tokenizer, and Y is gonna be our labels. Okay? If you remember, the output of the tokenizer had input IDs and attention mask, and we're gonna store those in different places. And then Y is our label. Okay? I'm gonna show you something that I haven't shown you before, which is that our get item doesn't have to be exactly 2 things. It can be 3 things. In this case, it's gonna be our IDs, comma, the attention mask, comma, the label. So any questions about this data set? It's basically what we have done before a little bit. So you create data set for training and data set for validation by just calling that. Xtrain and xval come from before, from the tokenizer. And then we do a data loader. The batch size in this case is 8 because I put it larger and I run out of memory. That's how you figure things out. You look at you can look at your GPU and see how much you're spending of the GPU, the percentage of the GPU that is being used to calibrate that batch size a little bit. See how much you can put in. And then you train. So what is the loss function we're using here? Yeah, binary represented with logic, right? Because we didn't put a sigmoid at the end of our project. So we have a training loop, we have a validation matrix, which is very similar to what we have done before. So this is just accuracy. And this is our training loop, which is very similar to what we have been talking about before. So this is our very, very normal PyTorch training loop. The only difference here is this one. So now your data loader is giving you 3 things instead of 2. So you just have to get 3 things. And your model wants 2 inputs. One is your basically your IDs, and the other ones are your attention. So and then you train, and you get. I have to train again because I had a little problem. So I have to train again to see if I get something better. But you get better accuracy than the other previous models. And you may say, oh, you got 93 over there, right? And now you're getting 95, 96. But actually, this also should train a bit more. But these are important for people. A couple of percentages is something that is important, right? And I didn't experiment too much. So this is I finished this 2 days ago. So I haven't been really experimenting. Can we get another model that is better? Can you do something better that could make something higher accuracy? So this is just kind of a very simple kind of baseline that you guys could try to train on. And again, you have to really look into the models, understand which models could be better. Think about that different models have slightly different, so the transformer models, there are like 3 types of them. So you might need to change something of what you are doing, how you call them a little bit, depending on the model that you have. But there are examples on the web. But this is kind of the basic idea. So the basic idea is that you get this type of output from the model or one part of the model. You have to cut it in the right place to get this type of output. And from here, you get your, so this is usually called the encoder. And from here, you train your labels. Okay, so I think I'm gonna stop here. And if you have any other questions, I'm happy to take them. Questions? A question?
I have one.
Yeah.
So in the training loop, you feed the model the X and the
attention. Yeah.
So what's the attention used for?
The attention is used because you are padding.
Yeah.
So the IDs are IDs, and one of the IDs happen to be 0, and this 0 is padding. So you're giving that information to the model.
So
You're
it
saying-
knows where is the pattern, right?
Yeah, it knows where the padding. That's the way we're using it right now. Attention could be something different as well, but this is the way we're using it right now. Any other questions? Good.
Net.
Yeah.
Can you repeat the questions?
So the question was like, what is the attention doing here in the model? Yeah.
So for each model, the code is going to be slightly different, but the general idea is pass the text through the tokenizer to the encoder and then train your model.
Exactly. So the basic idea is like models are gonna be different, but you pass your text through the tokenizer. If you are training in batches, in the first one, if you realize I didn't have batches, I was encoding one sequence at a time, so you don't have to worry about the padding. So in the first version that we did, we don't worry about the padding. Now, if you wanna train the model, then you do it in batches. And first you pass it to the tokenizer. The tokenizer is going to give you the IDs and the attention mask. And then you take it through the model and you train it. Yeah. Yeah.
I just have one question about the mechanics of this. If you are training, if you're fine-tuning a model and it's large, you probably want to be doing that on a GPU, right?
Yeah. Actually, this is the GPU. What I'm
But that's
using.
on your local GPU?
No. This is what you see here. This is the server that we have here that has GPUs. So this notebook is not on my computer. So I have two. This is the one before, and this is the one. So this one also is on our servers. This one is local. So the first notebook I can run locally, no problem. The one for training, I run it on my GPU. Yeah.
And if you're running it on the GPU, where is it living? In other words, supposing I want to teach it to translate French to English or something.
Yeah.
I do that, but I don't know where it is. In other words, if I'm training it in the cloud on Huggingface, that's not my private model anymore, right?
No, but so usually, okay, so let me just show you. So okay, I'm actually gonna show you here. So this is our, school GPU, that I'm now not able to. So this is not my physical computer here, but this computer is pretty much mine to use it. I share it with Miguel, maybe, and some, but now I'm also with. So it is my server. It's not somebody else's server. It's our server here. I communicate through that server to SSH. You can also run it on the cloud. You will have to upload your data to the cloud. So Google will give you 2 hours of free GPU training. And then whatever output you have to download it to wherever you want, right? But yeah, so I am talking to a server there. In this case, it's our servers. I think they are in downtown somewhere, but I've never seen them really. I talk to them through my terminal. So I heard they're cute though. Yeah.
So suppose you want to divide into a certain amount of batch, and then you realize you run out of GPU. Can you change the embedding size?
Yeah. So what you do is to change the batch size. So if I have, actually, let me show you. I don't know. Well, right now, let me see if I can improvise this a little bit. But you can. So I'm going to SSH. You see. So this is my SSH here to my server. So I'm SSHing here. Script that I have my. So you do this, right? And right now I'm not running anything. But if I start running, which I could, you're gonna see some percentage up going here. And what I monitor is the percentage of the GPU that I'm using. I could use a photo of them if I wanted to as well. I also share with Sona, and she might get mad at me if I just say everything all the time. So no, I mean I just use one thing, but I could train also on multiple ones, right? But so basically what you do is that the first time what happens is that you get out of memory error. You have to restart your notebook. And then you lower your batch size. At that point you go and monitor what this is saying to make sure that you are, because also if you can use a batch size of 30, it's better than 8 in general. So you want to see it's faster to train. So you want to see, can I increase my batch size? So, and you do it by looking at how much else memory you have, and then you increase a little bit until you get out of memory again, and then you realize it's too much. So that's kind of the. So if I start, I don't know if something's gonna break, but if I start training right now, which I could, let me actually just try to. I hopefully I have defined everything, which is not clear. Let me start training, and you're gonna see. Now is when everything is going to break. You're gonna see something's gonna break. X-train is not defined. Yeah, I shouldn't do this in front of you right now because nothing is defined. But if I train it, then you're gonna see that that this starts moving, and it says 89, 94, 98. So it starts telling you how much memory you're using. Yeah. Okay, guys. So I'm gonna maybe let it go, and if you have more questions, I'll be around here. Okay, thank you.